These degenerate electrons stop white dwarfs from collapsing. But they give these stars strange qualities.
Throughout the universe, a battle is raging, and it has raged since the beginning of time.
The cosmos is a vast, untamed wilderness, filled with wonders that defy logic and stretch the limits of our understanding. What if a star could sip the life from another like a celestial vampire? Or an asteroid, once feared as a planet slayer, is now set to glide past Earth in a breathtaking, once-in-a-lifetime event. From ghostly stellar corpses that refuse to cool to strange, empty voids in the fabric of space, the universe is a playground of the bizarre. Some of these discoveries reshape our understanding of the universe, while others leave scientists stunned and full of unanswered questions. As we uncover the secrets of the cosmos, one thing becomes clear. Space is far weirder, wilder, and more unpredictable than we ever imagined. Ready to journey into the unknown? The strangest cosmic mysteries await. Apollo orbit asteroids. Apollo orbit asteroids are a group of near-Earth objects that share or cross Earth's orbit, making them particularly intriguing and potentially hazardous to our planet. These celestial wanderers travel around the Sun on paths that not only bring them close to Earth, but also intersect with the orbits of other planets like Venus and Mars. Their ability to cross Earth's orbital path means that, in theory, they have the potential to make very close approaches or even collisions with our planet. Fortunately, astronomers monitor these objects very closely, and current data suggests that none pose an immediate threat. The group was named after the 1862 Apollo. Apollo, being immense, it's almost a mile wide, even sports its own moon, a little bit of one, that is. It's kind of mind-blowing that Apollo, being the archetype, was lost in space for 40 years and not found until its rediscovery in 1973. Within its intricate, multimodal orbit worm casting, using Apollo as a template, we see the beauty and potential danger of such cosmic objects, but also another living proof of our celestial environment, dynamic and ever-changing. As we track Apollo orbit asteroids, another massive celestial visitor with a name rooted in ancient mythology is preparing to make a close encounter with Earth. Could this one be a cosmic game-changer? Asteroid Apophis. Asteroid Apophis 2004 MN4 is one of the most well-known near-Earth objects, primarily due to its massive size and its upcoming close approach to our planet. With a diameter of about 1,480 feet or 450 meters, Apophis is significantly larger than smaller asteroids like HO3, making its proximity to Earth in 2029 particularly intriguing. The asteroid will pass near Earth on April 13, 2029, at a distance close enough to be visible to the naked eye, offering a once-in-a-lifetime celestial spectacle. Initial calculations raised concerns about a potential impact, with a 2.7% chance of collision in 2029, sparking fear. However, after further observations and refined data, scientists have ruled out the possibility of an impact in 2029. Apophis, passing through without any significant results 2029, was allayed, though there is expected to be an approach closer in 2036 too. It is not going to make any difference. There is a very low probability of Apophis type of asteroids getting an Earth hit once every 880,000 years. In case of an impact event like Apophis on the Earth, the destruction will be relatively regional. Tsunamis, earthquakes, and widespread destruction rather than planetary destruction. Apophis will go around the Sun, and it will not lose its gravitational link with the Earth. Low orbits of the Earth are significant because some important near-Earth objects can pass it. It prepared us to pursue any other impact in the future. Large impacts and catastrophes. Large impacts have played a pivotal role in shaping planetary surfaces and even the course of life itself. For instance, a colossal impact on the Moon, likely responsible for the formation of the Giordano Bruno crater around 4 million years ago, evidences the raw power of such collisions. Historical accounts even tell of 5 monks in 1178 who witnessed the Moon splitting with flames and sparks, a spectacle that, had it occurred on Earth, would have unleashed a devastating meteor storm. On our own planet, the impact that extinguished the non-avian dinosaurs 66 million years ago caused by an asteroid over 6 miles in diameter.
The star loses hold of its outer atmosphere. Its outer atmosphere drifts off out into space.
Stands as a stark reminder of the catastrophic potential of these events. Though such colossal collisions are rare, their effects, mega tsunamis, earthquakes, and profound alterations to the crust, are both dramatic and enduring. On planets other than Earth, large impacts are thought to be one of the key drivers of planetary evolution across the solar system. Models have proven that Mars, for instance, has been hit by such great impacts, resulting in mega tsunamis and reformulation of its features, significant deep and ripple-like structures showing the evidence of violence wrought by the event. However, they emphasize that there are very few events that could thoroughly sterilize a planet, and an impact that big would likely only lead to local devastation, if at all. Therefore, scientists are deeply interested in understanding how planets are formed by cosmic forces and in developing technology against disasters, such as those caused by a space impactor. The scars of ancient collisions are a record of a rather dramatic past and a guide to the safety of the future. White dwarf stars. White dwarf stars, the remnants of once mighty stars that have exhausted their nuclear fuel, are known for their extreme density and intense gravitational pull, but one of their most fascinating and destructive traits is their ability to eat planets. As a white dwarf form, it sheds its outer layers, disrupting the orbits of any nearby planets, asteroids, or moons. Some of these objects get flung into deep space, while others are pulled toward the dying star. When a planet ventures too close, the white dwarf's immense gravity shreds it into pieces through tidal forces, creating a glowing disk of debris around the star. Over time, this material spirals inward and gets consumed, leaving behind telltale signs of planetary destruction in the star's atmosphere. They identified the remains of planets in the spectra of many white dwarfs by finding elements like calcium, magnesium, and iron, which are usually involved with the cores and crusts of planets. This occurs because many white dwarfs still feed on the remains of other planets they once kept as part of their solar systems. Sometimes the whole world will have fallen too. These findings provide a peephole regarding the final destiny of planetary systems, as well as, in fact, including our own. When our sun eventually evolves into a white dwarf 5 billion years from now, it may too quite possibly feast on what remains of the solar system, an asteroid or two, a moon, and possibly the rocky vestiges remaining of Earth. Planet hunting clues. Astronomers have discovered crucial clues about distant planetary systems by studying the remains of worlds devoured by white dwarf stars. When a planet, moon, or asteroid falls into a white dwarf's gravitational grasp, it gets torn apart, leaving behind a distinctive chemical signature in the star's atmosphere. By analyzing these signatures through spectroscopic observations, scientists can determine the composition of the destroyed planetary bodies. Elements like iron, nickel, and oxygen suggest the presence of rocky, Earth-like planets, while lighter elements like carbon and hydrogen may hint at remnants of icy worlds. This process allows researchers to reconstruct the history of exoplanetary systems, revealing what kinds of planets once orbited these now extinct stars. Also, the remnants of these bodies facilitate a better understanding of how extraterrestrial planets die.
If you climb to the top of that skyscraper, you'd be outside of the white dwarf's atmosphere.
Certain white dwarfs express the water-enriched substances in the systems which hint at the presence of former water-inhabited planets or satellites. On the other stars, there are chemically rich elements that are very rare in the solar system that we inhabit. Change in the composition of the planetary matter with these characteristics is the same everywhere throughout regions of the galaxy. As these detections become clearer, the stage of the planet system's formation in the galaxy becomes less mysterious, as well as the reasons why some of them develop and others do not, and whether it was possible to meet lifeless worlds among the worlds of that age. In other words, they discover how planets have aged and died, and this has implications for the current search for planetary systems and planets that could support life outside our solar system, as the oceans within the planets provide a vast manner hypothesis. Strange white dwarfs that stop cooling. An intriguing white dwarf remains suspended in cooling, and it defies the classical model of stellar evolution, as it takes much longer to get colder than one would expect. In contrast, they are most times expected to cool down for billions of years, all the while losing their residual heat through radiation.
A white dwarf at its surface can be 500,000 degrees. It's even hotter in the interior.
However, it has been seen that some go through cooling so slowly that it is bizarre. As per the recent findings, such exceptions are supposedly the result of the extraordinary composition of white dwarfs that contribute towards slowing down the heat release, such as great magnetic fields or the process of crystallization that prevents cooling down temporarily. On the flip side, some white dwarfs may receive external sources of heat as they engulf some matter generated as part of the accretion from the surrounding debris, while some are triggered by the interaction of binaries with their companion stars. This new pattern challenges the understanding of stellar aging and also offers some dynamics of the dynamics in the physics controlling the remnants of dead stars. It is a call to action for astronomers who must further sharpen their models for stellar evolution and planetary system dynamics as well. Brown dwarfs. Brown dwarfs are quite interesting objects. They stand between main sequence stars and planets. Some people refer to them as so-called failed stars because they do not have the mass that would determine the continuing hydrogen fusion like that of true stars. Their masses can range from a little bit bigger than that of Jupiter to perhaps 80 times Jupiter's mass, thus softening any sharp borders previously drawn between massive planets and small stars. They are so dim and cold that they are hardly visible except through infrared telescopes, which have helped to locate many of them in hidden pockets of space. Brown dwarfs also show planet-like features, turbulent clouds, and complex weather-like others orbiting stars, instead behaving more like free-floating objects wandering around in the universe. Since they are failed stars, they do not fit comfortably into the standard idea of how planets develop, yet they tell us much about stellar and planetary processes. They may well redefine the boundaries between planets and stars. Luminous blue variables. Luminous blue variables are kind of the heaviest and most volatile stars currently recognized in the entire universe, famed for their uncontrolled brightness and the devastating havoc they wreak. Eta Carinae, among many, is the wonderful famous bright star, marking the disappearance event. These stars live for a very short time, burning down their fuel, millions of times brighter than the sun. They, however, lose massive amounts of material as they are removed into various portions of space. The best known among these objects is Eta Carinae. This unique binary system maintains a giant luminous blue variable, explosively erupting several times during the intervening epochs. The greatest of these disturbances was registered in near history, in the Great Eruption in the 19th century, when it was probably temporarily the second luminary in the heavens. Such eruptions, it is believed, show that a conclusion is approaching for such a star, which could be in the form of death by a supernova or even a direct fall into a black hole. The luminous blue variable stars are valuable in helping to trace the life of massive stars, their large conversions, and the enrichment of their environs prior to their final destruction through an explosive manner. Supernovae. Among the causes of death of certain stars, supernovae are something powerful. They can be split into two main classes, Type 1 and Type 2. Massive stars, which are at least 8 times more massive than the Sun, end their life by their fuels being exhausted and their cores collapsing under their own gravity. This leads to a moment of catastrophic explosion. It releases a tremendous amount of energy that reveals the galaxy in an instant and throws iron and oxygen back into space, two of the essential components necessary for the formation of planets and life. The first way those supernova events can occur is when a white dwarf in a binary system accretes matter from another star until it becomes massive enough to explode thermonuclear. It is also important because type Ia are used as standard candles to measure distances in space. The heavy elements found in the interstellar medium came from supernova events, which is the largest chemical enrichment event in the history of the universe. In fact, it will guide the formation of the future stars and the planetary systems they bring with them. as these eventually evolve into the systems that will continue for millions of years. Artificially created extreme heat. The production of artificially created extreme heat is a playground research pursued to advance the frontiers of physics and materials science through producing extreme temperatures, realizing that temperatures compared with sunscapes are really hot. The aperture of millions of degrees Celsius has been achieved under controlled conditions in laboratory experiments, often with the help of devices such as the International Thermonuclear Experimental Reactor and the National Ignition Facility, that aim to recreate the action of the fusion energy process occurring within stars. One central goal of the project is to underline nuclear fusion research as a possible future energy source, since this will produce almost unboundedly clean power. In addition, it serves those astronomic phenomena like supernovae and black hole accretion disks that are also concerned at the moment. Beyond energy production, this research plays a key role with respect to other advanced material developments, aerospace technology, and testing space exploration developments requiring heat shields for atmospheric re-entry, says Wesley P. Kennelly, the chairman of Symphony Space. Scientists should master artificially induced extreme heat to meet the specific technological challenges facing them and deduce the most vigorous phenomena in the universe. Cosmic kissing stars. Cosmic kissing stars refer to close binary star systems where two stars orbit each other so tightly that their outer layers physically touch and merge over time. These contact binaries share gas and energy. This often leads to spectacular stellar interactions. In some cases, they eventually become a single but larger star, or even move on to triggering powerful stellar explosions. These systems are of utmost importance in understanding stellar mergers, mass transfer dynamics, and the evolution of massive stars, as they can bring about luminous red nova or even supernova events. When stars come dangerously close, their bond can lead to explosive outcomes, while in other corners of the universe, some stars refuse to die, feeding off the life of their neighbors. Variable stars. Astrophysical objects vary in creativity, variety, and qualities. But one significant discovery is that most of these objects come in a wide range of properties, and that a key part of this is the subset of variable stars. These owners of significant changes in the visual and energy behavior over time contain another strange subgroup. Vampire stars are classic examples of such systems. When two stars orbit each other in space, one sucks mass from the other, counteracting the natural inclination to loosen one's bonds with the mother giant. Conversely, in the case of zombie stars, they are called such because they are the leftovers of white dwarfs that survived a small supernova explosion. Unlike regular stars which are completely destructed, this star's behavior traces all the complications of star evolution, supernova explosions of different corridors, and the intricate star life cycles of the stars in the sky. G. Objects near the Milky Way's center. These G objects still exist around the center of the Milky Way, dangerously orbiting close to Sagittarius A, at the heart of the galaxy's supermassive black hole. Discovered in early 2000, they present an object that appears to be a strange fusion between a gas cloud and a star. They tend to elongate when they get closer to the black hole, but do not show any sign of being torn apart. Scientists suggest a possibility that these objects may be massive stars cloaked in denser gas and dust generated from possible stellar mergers.
20 years ago, we didn't know for sure that there is a black hole at the center of our galaxy.
Given this, they are very important to researchers for the study of black hole interacting activities, galaxy evolution, and the dynamics of extremely energetic events in the heart of our galaxy. Mysterious lunar flashes. Transient lunar phenomena are sudden occurrences of bright light on the lunar surface, which scientists refer to as mysterious lunar flashes. These expeditions have been around for centuries. Most often, these flares last anywhere from milliseconds to minutes and appear in the form of brief glows, flickers in color, or even intense bursts. Scientists think that powerful electrical discharges sometimes accompany the disturbances, while in an alternative theory, Electrostatic discharges, due to ions associated with the solar wind, could cause very short, intense surges of light. Some say these discharges are from an accumulation of bronzing gas escaping the moon during seismic events. Tracking such phenomena also explains the current lunar activities in terms of geology and their hazardous nature to possible lunar missions in the future. Space trash. One of the growing dangers to satellites, space missions, and the International Space Station, ISS, includes exploding rockets, or smart space junk. Debris such as defunct satellites, expended rocket stages, or fragments from collisions travel at speeds of up to 17,500 miles per hour, creating enough velocity to turn a single piece into a catastrophic force of destruction when it collides. For example, there are about 10 to 20,000 objects that have been made to revolve around the Earth in space, and millions more cannot be accounted for. The likelihood of a collision escalates as these objects tend to get closer to each other, all of which are floating on the same paths. Indeed, collisions between two big objects, such as defunct satellites, can lead to the creation of thousands of smaller fragments orbiting the Earth. Thereby, destructive chain reactions known as Kessler syndrome could follow.
We are surrounded, our planet is surrounded by this cloud of space debris.
Measures are being taken for the mitigation, elimination, and reduction of space junk, including developing self-destructive re-entry systems for spacecraft, active debris removal missions, and the enforcement of more stringent rules for decommissioning satellites. One of the crucial issues facing humanity as they colonize space is to deal with space debris for the sake of ensuring a sustainable and benign future beyond Earth. Venus and Mars as possible past havens. Venus and Mars were worlds similar to Earth, though quite distinct right now. These planets may likely have turned into a place for life. Mars, with its dry, cold deserts today, is a strong proof that it had running rivers, lakes, and even a vast ocean, all sustained by a thick atmosphere billions of years ago.
Mars may have been more like Earth than Earth was at the time.
Scientists say that the loss of its magnetic field allowed solar winds to strip away most of its atmosphere, leaving it almost the barren, frozen planet it is today. Venus is another story. It's scorching here, lying on its surface, steel melting even. The models still postulate that Venus could have had Earth-like temperatures along with liquid water for up to 3 billion years before its runaway greenhouse turned it into a toxic bake oven of super high pressures. If life actually existed on either planet, their most likely places developed into habitable environments during their early times when the climates changed. Exploring these planets will allow scientists to see how planets evolve and what makes them truly fit for supporting life. Neutron stars. Neutron stars, which are a type of stellar remnant from the destruction of highly massive stars that end in a supernova event, are known for having an inescapable density of the stellar core.
Neutron stars spark into life amid the death of their parent star.
Just like it was conquered in 1877, when that was a new land, loaded into his reindeer cart and taken to Skellefteå, the navigation experts chopped down the vast wilderness of the page, mass within these massive stars, after finishing burning its hydrogen well into the heavier atomic compounds, has been quantified enough to overtake Peters that the Sun cannot escape, except through deformation and shrinking well unto defying the joint flexibility of molecular arrangement within the structure of the star. The addition of black holes is important because it has also happened in more cognizant masses. The Bootes Void. Bootes Void, otherwise often referred to as the Great Nothing, is one such void that bestrides a massive scope covering approximately 330 million light-years across and holding very few galaxies within it. Its place in the constellation Boötes is a grand nothingness that astrophysicists find intriguing and tedious for large-scale structures. Created in 1981 by Robert Kirshner and his team, the void is so sprawling that if humanity became located at the center of the Milky Way, we wouldn't see another galaxy for nearly 1 billion years. Such voids may be gone without known. Boötes Void is unique because of its abundance and huge scale. most likely giving researchers the information needed to determine the early cosmic expansion or dark energy, played a role in shaping a lot of its emptiness. Scientists believe this supervoid was carved out as smaller voids, merged over billions of years, showing that the universe is not equally distributed like a bunch of galaxies filled in between some empty spaces. Nova and supernova. Kisses. The kisses of nova and supernova refer to the dramatic interactions between binary star systems, where one star's fate is closely intertwined with that of its partner. In these systems, a white dwarf, very frequently the remnant of a once massive star, is stealing matter from a nearby partner, which could be a main sequence or red giant star. This accumulated hydrogen just has to reach a critical mass level and can then induce a nova explosion, represented by sudden flaring brightening due to runaway nuclear fusion on its surface. And if this mass stealing continues on and reaches over the Chandrasekhar limit, 1.4 times the mass of the Sun limit, the white dwarf will detonate as a Type Ia supernova, which means that such an explosion completely destroys the star. These cosmic kisses between two stellar companions are fatal. However, at the same time, they are essential for general cosmic evolution, since they spread out precious material just like carbon, oxygen, and iron over the universe, so that future generations of stars and planets will be sown with it. The ultimate fate of the universe. The issue of the universe's future end is that which has to do with dark energy, the expansion of the cosmos, and space-time itself. Concurrently, more recent studies analyzing dark energy note that the present cosmic motions is a direct result of an increase in the dark energy, and the Big Freeze possibility was therefore noted to be most acceptable. At this time, the forecast would be that galaxies will pull off from each other, stars will exhaust their fuels, and the whole universe will fade away into a cold and pitch black, even in places where even black holes would be far apart as a result of Hawking radiation by which they would evanesce later on. There are some other competing theories. The Big Crunch, which allows for the universe to recollapse over an infinitely large matter core, also known as a singularity, and the Big Rip, where the tearing effect of dark energy is so immense that galaxies, stars, or even atoms fall apart. Said exact condition is not expected in the end, but the extreme fate of the universe will be the proportionality of dark energy factors and the general space-time curvature condition. Life on the ISS. Living and working on the International Space Station, ISS, offers a unique, otherworldly lifestyle that demands strict routines and meticulous planning. Astronauts aboard the ISS rely on carefully scheduled crew care packages, which include not only essential supplies like food and water, recycled and stored in specially designed pouches, but also personal mementos to help ease the psychological strains of extended space missions. Their daily life is filled with both routine and adaptation, from using rinseless shampoo and pressurized space pens to ensuring that no loose items like crumbs disrupt sensitive equipment. Every detail is engineered to thrive in a microgravity environment. Clothing is chosen with care, 100% cotton, for instance, to avoid shedding fibers that could float and interfere with operations, illustrating how even the simplest aspects of life are rethought in space. Astronauts' issues when in outer space are difficult to handle indeed, but not in about the management practice of celestial voyage only. Even on the lightness of unequivocally low energy consumptions, the body of the person is exposed to a wide range of such in determining the structure, as the strength level is not the same. From muscle shrinkage, increase in turnovers of bone loss, in the order of 2% per month, down to lids ever so gently opening only to reveal fresh layers of dead skin as the old corns fall off. These physical problems, such as vision, are worse than other syndromes, as has been pointed out due to existing radiation exposure, again, as well as there is also the aspect of social isolation in space that influences people. Thankfully, in the process of the physical activity program, which includes the exercise regime and the support system, the tacking of their nutrition and sleep patterns, as well as how men deal with the gravity forces, is included, supported by the policy that has been developed to assist the longer-term maintenance of the disorder in the relevant population, which will not be the case for the ISS. While astronauts navigate the challenges of life in space, another mysterious object just beyond our atmosphere is offering scientists a cosmic puzzle that could shape our understanding of Earth's history. Asteroid 2016 HO3. Asteroid 2016 HO3, also known as Kamo Oalewa or simply HO3, is a fascinating near-Earth object that may actually be a fragment of the Moon blasted into space. Discovered on April 27, 2016 in Hawaii, its name roughly translates to a fragment that seems to wobble, which is fitting given its unusual, fast-spinning orbit around our planet. Although its size is relatively tiny, comparable to a small building or about half the size of the London Eye Ferris wheel, its close proximity to Earth has captured the attention of astronomers worldwide. Some studies suggest that this asteroid may have originated from a colossal impact event on the Moon, potentially linked to the formation of the Giordano Bruno crater. HO3, the near-Earth object, won't cause a collision. Scientists declare it can become a quasi-moon for Earth in approximately the next 300 years. Thus, the wild and stable looping orbit around Earth, which brings the asteroid close to, thus far from, Earth. There does exist a theory stating that, in the longer term, millions of years, it may crash into the Moon if somehow pushed into the Moon's territory. But, in the present scenario, the calculations rightly support the determination that it does not pose any threats to Earth. This charisma and hesitation make HO3 an interesting subject, which determines the behavior, structure, dynamics, and origin of close objects concerning Earth, and further provokes further engagement into possibilities for life's building blocks to transfer across space. If you enjoyed this journey through the cosmos, don't forget to like, comment, and subscribe for more mind-blowing discoveries. Have any thoughts or questions? Drop them in the comments below. We love hearing from you, and make sure to check out the next video on the screen to keep exploring the wonders of space. See you next time.